We're talking about basically, so we have lambda functions. They are doing what? They're just basically saying, okay, I want to define a function. Okay, in one line, I don't really want the function to be called elsewhere. Well, it doesn't have to be called elsewhere, so I don't need the name. So sometimes here you are also gonna define function as outputs. Okay, so that's what we are seeing right here. So one of the examples that we did earlier is that, um, so basically the derivative function is a function that I'm outputting, given an input f. Okay, so when the input f is a function, so here this is a really naive way I'm returning the derivative as like a estimated derivative, like using a secant slope to approximate the tangent slope, right? But the key idea here is that we are allowing output as a function. So here, then you can see that derivative of f is a function, and then you can evaluate that function at any input point. Okay, so that's the key thing here. So lambda function is not really special, but it can allow you to return a function as an output. That's what's special here. And then the example that we have seen from earlier is that, okay, now what can we do? So for all the powers 1, 2, 3, I'm defining the power of f as this lambda function right here. So basically for each I, I'm returning x to the I, right? And now if I want to get the list of the derivatives, okay, so the list of functions is exactly this kind of mapping that I'm mapping the function power of. You can say that's a functional. I'm mapping for each power to that power function that I have there. So here this is the high level idea that we were not able to do before, okay, but we can. So the function list here is actually a list of monomials. Okay, this is very important. This is something. Yeah, let me just highlight. So just use the highlighter to circle it. Okay, so this is something we couldn't do before. Okay, so now power of is a function that return is let's call it a functional to just distinguish. Okay, so the power of is essentially a functional. You give me a input I, it's the power. I'm gonna return you a function. Okay, so you give me something, I can return you a function. You give me something, I return you a function. Let's just say it's a functional. So now I'm specifying the functional, and I'm mapping the powers. So for the list of powers, I'm gonna get a list of monomials, right? A list of functions. And here I'm doing the mapping, but this map function gives me a data structure that's not really a list. So if I want to get a list, I just use the conversion of a list at the outside. Okay, so that's the list conversion. And then for each element of this function list, okay, func list is actually a fun list. Is actually just a function, okay, a monomial there, okay, on the right hand side. So now if you do derivative of f, evaluated 2, what does that do? So that's the approximated derivative for each monomial in the list. Okay, so essentially the high level idea is that you want to get the derivative of x to the 1, the derivative of x to the 2, the derivative of x to the 3, right? And then the x is specified as 2. Okay, so that's the argument. And derivative is another functional that we talked about earlier, okay, from earlier. So this is another functional. Prior functional. Right. So that gives you a systematic way to define, just construct a list of derivatives once you are given the list of functions. Okay. And of course, if you're doing the evaluation of the functions, you can just do what? You can just do for all f in my function list, right? F of, let's say, 3. Right? So if I want to compute f of 3 for each function, then I'll just do f of 3 for all f in fun list, right? So these are all the things that there are many other options that you can do. Basically, now it's we have this high level thing of list of functions that you can write. Okay. So now you can see that the list is a really flexible kind of data structure. So it can be a list of characters, it can be a list of floats, it can be a list of mixture, okay? It can be a list of functions and other data structures, other data types, sort of mixed, right? It's really up to what kind of element that you want to assign. So, question so far? Okay, so now the map function, what's special here is that indeed it will give you the data structure that's just map. Okay, it's just called a map. That's the purpose of this code cell. So we have the W range from -5 to 6. So it tells you what? It tells you I'm starting from -5 all the way ending to 6 minus 1, which is 5. Okay, and that's exactly that. And then here I have what? I have A is the squaring. See this the function here is squaring the input, and here I'm mapping W's to the source. So A and B, they are the results of the map, right? And then here, what you can do instead of doing the list. Okay, so earlier we just do the list of the map, which is conversion. This is the conversion to a list. But then you can convert it to a set. You can convert it to a tuple. It's really up to your choice. So this is conversion to list. This is conversion to set. And remember, a list of something is, this is kind of like a function call, right? So it will give you another output, which will not overwrite your original data. So if you're now looking at the type of A, okay, so the type of A is a map. So this is very interesting. So it tells you the output of a map is the type of a map. So that's a special type. So if you think about the types of data, we have a lot, right? We have for individual data, it's like a float, integer, characters, right? And then we have functions that can be returned as type. And here is a map. Okay, we have also the list and sets. So in particular, you can define. Okay, you can convert it to list and sets. So notice here the squares they're actually -1 through -5 squared and 1 through 5 squared. So you see this kind of symmetric behavior of the numbers. And if you want to construct a set, right, then the set doesn't have repetitive elements. So essentially, when you convert it to a set, then those repeated elements will be killed off. Okay, so that's these are different kinds of data structure that you can pass to. Okay, so that's what's interesting here. So map gives you type map. Okay, so that's what's special here. All right, so to quickly run that code cell, where is it? It's here. 7. So let's also see the type of, so we already see the type of set B is now is well, the set B is a set, right? Still, I want to print. Yeah, you see. So indeed, there's several different kinds of types that we have seen right now. So these are all different kinds of sort of memory assortment that we are looking at in the Python code. Print and print. So the point here is that, okay, remember, A here is the result of the map. And then even if we do the list, right? So we expect the list of A is going to be a list, which is printed here, right here. But now it doesn't really modify the type of A. So the type of A is still a map. Okay, so that's just the purpose of this. Wait, well, yeah, right. Okay, so this if if you print the type, it's gonna be class map, class set, which is something we're gonna see coming up. Okay, so in object-oriented programming, we have a class, but basically that's the data type. So that's good. So yeah, so you do have a freedom of choice for the output data type. Okay, it could be a set, could be a tuple. Right. So that's pretty much it about the first part of the entire course. So and of course for today's lecture is firstly lambda expressions, they are used to create functions that in one line. Okay, so you just specify lambda and then input colon and the way that you want to output your calculate your output. So essentially, you are not specifying the name of the function in that one line. If that's the case, then you are not really calling it elsewhere. So, and then list comprehension is also basically a way that you can just iterate from your old list, okay, to construct your new list. And we have seen from our example that, okay, if you have two lists, A and B, and you want to add elements from A and B, one from each set, and then do the addition to construct a new list, you can also do that. So it can be somehow combined from multiple lists. Basically, it's really up to your choice. And also for list comprehension, think about the conditionals that you can also include in choosing the elements. Okay, so those are all options that you can utilize. So that's good. Okay, so yeah, make sure to play with this kind of code because essentially they're going to be really helpful in your future data analytical tasks. Okay. All right, so intro to object-oriented programming. So the key here is the term object. So basically, the objects are the things that we want to work on. Okay, we are allowed to work on. So, and basically, in the terms of the name, it's basically saying, okay, we focus on the manipulations and the tasks we can perform on the object. So that's the object-oriented programming. And this gives a way to view objects we would like to compute with as both collections of data and functions, methods. So usually, okay, when we talk about the way to handle the objects, it's going to be called methods. Because they are not necessarily functions. Remember, the functions that we have introduced from before is that, okay, define a def function name and then colon with the operations, and you have something that you return, right? But then here we would call many of the things methods because like you see like a pop, right? So there are methods that directly manipulate your old data. There are methods that manipulate the data and at the same time will return something. So they are not necessarily functions. So here we prefer to call the things that we can do to these objects as methods. Okay. So here, yeah, this, let me scroll a little bit. Okay, so that's yeah. Let's just zoom up. So here, let us just convert to our notes. That's more convenient. Okay, so all these terms we're gonna talk about. Okay, within the coming up sections. So object. Okay, so that's what we just mentioned. So we focus on all kinds of objects that we want to manipulate. Okay, and today we're going to talk about what the class is, and then the methods. They're just basically the operations that you want to interact. Okay, with your class, and of course, for any class that you care about, there are special features. So let's say for any object, okay, or for any object that you want to study, right? So there's a lot of different kinds of information that you can extract depending on the context and depending on the knowledge. Okay, so the deeper understanding that you have on a certain object, then there will be more kind of data that you can access. So different kinds. They are the attributes. Okay, they are the features. Um, and what else? We have seen abstraction, right? So basically, abstraction is a way that when we're writing a function, you kind of form like a black box. You only specify inputs and outputs, and then you sort of hide the information, right, for your particular implementation, right? So those are the things that that's already what we have discussed before. Okay. So, and then there are three other terms that will come up a little bit later. Okay, but today we can definitely talk about class, method, and attributes. Just to make sure I'm not forgetting anything. Okay, so here to somehow highlight. So these are the things that we operate on, okay? Things to operate on. So think about the things that we have seen, okay? Objects. So the characters, okay, the strings with different types, right? Floats, integer, character, they are objects. Function, they are objects, and lists, tuple sets, they are objects, and then the map. Okay, well, so the output of that mapping the results, that's also an object. So we do have different kinds of objects within Python. Okay, so they basically relate to particular tasks that you focus on. Things to operate on with attributes. Okay, the attributes would be basically certain information associated to the object. Okay, and then the operations, they are the methods. All right, these are the operations. All right. Okay, so let's look at an example. For instance, here the object now is a car. Okay, so we care about the car. And then to specify a car, then there are a few very fundamental information. Like if you want to specify a car, at least you would want to mention, okay, what's the make? Okay, what's the brand? Okay, what's the model? Okay, let's say if my car is Buick, then what kind of Buick is it? Right? It could be something like uh, let's say Encore. So it's somehow you need to specify that, and then specifying those is not sufficient. Okay, you still want to talk about the color for someone to try to identify your car when you tell them to. So color and then let's say the year, right? So these are examples of the attributes that you may want to access or may want to keep as a record. Okay, so these are attributes. Of course, there are other more interesting attributes like, okay, when I care about how the car travel, right, then there will be speed. It could be zero. It could be some positive number. Uh, and then you may just want to trigger certain alerts if you are overspeeding, let's say in the automated driving system, right? So those are so basically it can get complicated up to the tasks that you try to handle, and it's also really up to the domain knowledge. Okay, so if you know very much about the car mechanisms, then like let's say the engine, then you will have a lot of attributes for the engine um, alone. All right, so that's a lot that we can do, but those are the attributes. And then, okay, of course, what are the method? What is a method? A method basically is just the something that you can do to attributes. So here we can say, let's say we want to start a car, and then we want to maybe turn off the car. Okay, so those are the things that also so you need to define attributes, right, associated to whether the car is on or the car is off. So then to start a car, you would want to change the status of that car from being off to being on. And then when you turn it off, then it's going to be switching that attribute again. So that's these are the things that you can perform on a car, right? So let's just begin with really fundamental settings with only a few numbers of features, okay, attributes. All right. Now, so that's the starting point, right? We have a car, and then we want to set it up. That's the class that we want to define, and then there will be really fundamental attributes like make, model, car, color, year, and then we also would want to, let's say, specify whether a car is on or off, right? So those are the things that we want to do. So as a starting point, okay, so here these are the things we can focus on the nodes. Yeah, this just quickly highlight. This is the operations, okay. So operations to object. That's what's called a method. So operations you can do to the object. All right. So the way that we implement objects with their attributes and the methods is to define a class. Now, to define a class is different from defining a function. So when you define a function, you say def and then function name and colon. But here, this is very special that for class, we have the reserved word class. And then the class name is now a car is really up to your choice. Okay. So the class in the front is reserved. So here, this is very important. So in this kind of like a Python intro course or like a programming intro course, this kind of topic starting from today, this is the thing you definitely want to learn and get out of the course. Otherwise, if you don't know what a class is and how to set it up, then you pretty much miss the essence of the course. Okay, so this is very important. So And this is very special. In other languages, they may treat it a little bit differently, but for Python, they do it this way. So class is the reserved word, and then the car is the class that you are trying to define. And then here, we need to do this initialization, okay, of our object. This is very special. So what's this? I'm circled in black. This is underscore, double underscore, okay? Double underscore. And then the first 4 letters of initialization, and then double underscore again. So this is also reserved. So what does it mean? It means is well, it's this is like a reserved function that's basically initialize your attributes, or basically the variables. Okay, so and here, what are the variables? The variable here is self, make, model, color, and year. So notice we only specify. Yeah, let me put an underline in red. Let me think. Yeah, let me put it in black. So these are the ones that we just mentioned. Okay, so for car, to identify a car, we need make, model, color, and year, right? So those are the things that we want to specify. But then what's self? Self is like a default. Okay, so this is like the keyword referring to the name of your name of your car. Okay, the name of your object. So two things are different. A class is kind of like a set. Okay, just like but we call it the class. But then the object is one of the elements of your set, and then the self is the name of the object. Okay, so let's say my car and your car. So the self is basically the characters for my car and your car. So that's the self-referencing in a sense. Okay. So this is what did I write here? This makes me a little bit confused. This is the name of object. Okay, so that's the self-referencing. Basically, when you yeah, we'll talk about it later, really soon. Okay, so that's that. Here, okay, the underlying black part, those are what? Those are sort of like the inputs of a function. Then they're gonna be fed to these lines. So those things, the make, model, color, and year, those variables you can change to, let's say, A, B, C, D, whatever way you want. You just they're just the inputs of this initialization function. So you can change the right-hand side of those following lines accordingly. That's totally fine. But what's special here is that, once again, initializing our object is basically saying I'm going to define a bunch of variables. What are they? They are self, which is the name of your object. Yeah, let me circle that. Dot make, dot model, dot color, and dot year. So that means what? That means, okay, let's say I have a car 1 and a car 2. Okay, so those are the names of my car. I'm gonna, yes.
I just had a question. So self is predefined in Python. It
Yes.
always has to be self when you're using.
Yeah, you need this.
Okay.
Yeah.
All right.
For basically, it's the self. You need to include it before all the features. This is reserved. Very important. What's that? That's basically saying, okay, so this is what I'm trying to say here right now. So let's say I have 2 cars, car 1 and car 2. Those are the names of my car. Okay, so then I specify the features whatever way I want. But when you try to associate the features to these 2 cars, what does the Python, what do you want the Python to do? You want the Python to have the variables car1 dot make and just the car1 dot model, car1 dot color, car1 dot year. And then for car2, you want to do the same thing, but it's car2 dot make and car2 dot model, car2 dot color, car2 dot year. So you wanted to do systematically, which is why they have self. Basically, whenever you do, so we're gonna see how it's gonna be implemented later. Whenever they see a self, they're just gonna capture this. Okay, they're gonna capture the name of your object to be the string of self, and then they're gonna feed it to initialization the variable the beginning part. Okay, so you're gonna define the initialization is just saying I'm gonna define a bunch of new variables for each attribute per your object. Okay, so that's what's happening here. So basically you will have car1 dot make, car2 dot make, car3 dot make, and those are the variables that are you're gonna be able to call globally. Yes.
So this is like the foundation for like, if you import numerical Python or scientific Python, this is kind of like the most primitive foundation of it.
Yes.
Okay.
So basically, whatever you see, like something dot something, that's basically doing this.
Okay.
So you have a class, and then you are getting the operations from that class. Yes.
Thank you.
Exactly. That's a very, very important comment. The foundation of it. Yes. Make sense? All right. So yeah. So the initialization step is what you need for your object. Okay. So that tells you, okay, now for whatever object, I'm gonna define these four variables, and they are just the car name and then dot each attribute that I. Okay, interesting. So well, the screen still works, which is good. So okay, so now and the following line is basically this is like the just running this kind of baby class. Okay, so my car equals to car, and then I have four inputs: Honda, Accord, Red, and 2013. Okay, so these are four strings. They're just basically the values of my attributes for my car. Okay, so now whenever they see this, okay, so my car is going to be the called as self. Okay, so that's self. So here notice car, it's sort of like calling a function, but it's essentially calling a class. And you have the four features. They are just associated to make, model, color, and year directly. And self is now capturing the name of my car. Okay, so that's there. So then you'll be able to print my car.year. Okay. So my car.year is what is actually catching this variable. Okay, this variable. Calling variable. All right, so that's going to be 2013. And then of course when you do my car.make, so now the system knows, okay, this is my car, which is already in the system, and then my car.make is calling that variable, which should be Honda. All right, so associating to that. Make sense?
So if
Yes,
we were working with the two cars, like in the example above, you do my car 1 and then my car 2.
you should be very specific about the name. So here, if I say car 2 equals car. So yeah, it has to be consistent with your the way you define. So it's a capital C. So whatever. Okay, so then you would need to do car2 dot make. So exact same name. Okay, so yeah. So that thing is gonna fed to self. And everything else is gonna follow along the way that you feed the data. Right? Very good question. Okay, very important. Make sense? Yeah, make sure to play with this running this cell. Okay, and of course try calling my car dot color and my car dot model. Okay, so yeah. Yeah, and then of course the lower part is about the description, okay, the explanation. So double underscore init double underscore and self. What are they? So every time the initialization creates new variables for each object, okay, and each attribute, okay. So this is per object per attribute. So indeed, you can say in many computer languages, they would say you need to sort of like determine variables before you feed into data. So that this is the step of doing that. Okay, so that's creating the new variables. So these are the attributes, and then we create the object my car. So that name is gonna be self. Okay. So yeah, right here. So the variable name will be populated to self. Okay, so that's there. So and here I want to highlight that, okay, what's different about a class and a function is that for functions, so if you just erase class car to be def car with inputs and then a colon, then that's essentially having all the variables being local. Okay, so only the return thing is going to be global. But then here, a class, every attribute is global. So here, this is you see that I'm able to access this variable outside of my function call. Okay, so right, so that's the global variable. Okay, so this is a very important thing here. So that's very different from functions. Make sense? Okay, so basically, this is whenever this is the reason why class is designed this way. So you want to have the data associated to objects, right? But then you would also want them to be accessed the globally. So that's a distinction from function. Okay. All right, methods. So here above we have the object car, okay, and the attributes, the basic ones: the make, model, color, car, year, to identify a specific car. But then what operations we can do? So of course there are many that you can imagine, right? So later for the live coding session, we're gonna play with the house. Okay, so basically depending on what kind of features you want to do to the house. Okay, operations you want to do. Let's say for a car, you can say, okay, the speed is of course one thing, and of course if you want to think about, let's say, opening and closing a door, uh, scrolling down the window or whatever. So those are many things that you can do. Here, let's think about getting something new beyond the initialization. So here they have a start, we have turn off, we have first gear, second gear, and we have the check speed. So those are the operations that are basically the methods. Okay, so these are the operations that we can define. So now here, this is like defining a function. Okay, so uh okay, right. So you see reserved. Okay, so define. Right. And now notice we have something new. So when you talk about whether a car is let's say running or not, okay, whether a car is on or not, of course. So in terms of the mechanism, you want to turn it on, and then it will be able to speed up and slow down. And then when you leave the car, you want to switch it off, right? So those are systematic things you want to sort of like model. Basically, then there are things like, okay, if my car is off, you shouldn't have a speed, right? So there are certain things that you want to implement when you are writing the code. But then here, what we are doing is that, okay, I have the operation start. So I have this, okay, we have two more features, attributes. They are speed. Okay. So self.speed is basically for every object is going to associate to a speed. And initialization is 0. Okay, so that's the initial value. Initial value that you want to set. So let's say 0. And then the initial Boolean variable for whether the car is on or off is now false. Okay, so by default it's off. So that's this. Okay, so the speed then on. Okay, so this is representing on or off for a car. All right, and then we have the operations. If you want to start the car, then you see we start self. You see self again. Okay, so that's the reserved word for the name uh, of your object. Okay, name of object. So all right. So basically, start is just switching the on or off attribute to be on to be true. Okay, if you want to return some string, let's say on, that's totally fine. But here if you are using Boolean, let's just do true or false. And then turning it off is switching to false. Okay, so these are related to self.on. Okay, and then we have we can change the speed. So that's the first gear. The speed is 10. The second gear speed is 30. And check speed is saying, okay, answer. Okay, this is return a string, return a sentence, return. You can do f string as well. Okay, so here this is returning a string which tells you a speed. So of course you can say, why not we just call self.speed? Remember these attributes of a class that can be called from the outside, right? The global. But here, I would say in terms of experiments, there are a lot of data that you can output. So if you care about a certain attribute or a certain parameter, you would want to somehow predefine a output function so that eventually the things can be done in a more automated way. Okay, so that basically when you're getting the data of the experiments, uh, the program tell you what that is directly. All right, so that's really common practice for your own sanity. Okay, so for ease of understanding output. All right. So yeah, I think the rest of the stuff is just playing with this code. So any questions so far? So yeah, let's play with this code. So we see what's going on for the class, right? Um, so this is run my class car, and then I can play with certain um. So I can have my car, and I can let's try another one, my car two. Let's say car two, just instead of my car. So no wait. Yeah, let's just say car two. So the name is just different. So let's say Buick and core. Let's make it brown, and let's make it 2015. So now let's play with this. Here, this you see, there's nothing output, right? So basically, what does it do? So basically, we have a my car as a name that will be fed to self, and basically, you will be constructing self that make that this is basically the attributes that we have seen from before. So let's see. Let's turn on the car. So remember earlier for the initial parameters, these two ones, okay? So we have the new attributes being the speed is by default 0. The car is initially off, right? So here, let's try to make it on. So now, so, excuse me. This is calling the variable, whether the car is on or not. So the car is off, okay? So here, car.on is saying whether the car is on or off, and by default is off. Now let's start the car. So this line is the previous line is checking the variable, okay, calling the global variable, and then let's start the car, and then we call notice to start the car, okay. So we only change the variable, but we are not returning anything, okay. So you may not really see anything special. Wait, yeah, there's no output. And then let's check the status of the car again. Now it's on. All right. So just yeah, it's a little bit too large to fit. Does it look clear? Well, yeah. Does it look clear? If not, then I can still zoom out. But here basically, originally, the self dot on was off, was false. But then I start the car. So what does it do? It just switch to on. Okay, so I just turn on like using the key, and then I call the variable again. Okay, so this is global, so I'm calling it, and now it's on. So let's power it off and see what happens. So turn off is just make sure that your function call. So here they have brackets because what? Because this is indeed you are defining functions. So that's just saying we don't really have. We just use default input. Okay, so that's self. So I just power it off, turn it off, and see what happens. So now the car is turned off, right? Um, and let me see. My car first gear. The first gear, I think that it will change the speed, and then we need to print the speed. Okay, but yeah. So my car first gear. So remember earlier the speed is 0, okay? Now if I switch to first gear, it changes the global variable, but you still want it to reflect. Then either you call by car speed, but you need to be certain about your variable name. Okay, so that's something you may not remember when you didn't run the code for some time. Okay, so that's why here this kind have this kind of speed check function that you can direct without referring to the variable name. You can directly check the number. So so similarly, what I can do here is um, also check the speed for my car two. Okay, so print. Remember, check speed is actually returning you a string, so I indeed can do this print. Wait, oh, my car two is not defined. Car two is defined. You see the problem? Yeah, so you need to be really careful about the thing that you my car is established an object earlier. Car two established an object earlier. Okay, but so that's indeed as expected. Okay, so we have switched the gear of my car to first gear. We haven't done anything to car two. All right, so that's as expected. Any questions so far? Yes.
So the when you initialize it, you then make it into a global, the attributes of the global variables, correct?
Yes.
And then when you call in the define function, then you allow those local variables to mesh with those global variables. That's how that works.
Yeah, so these are just changing the values for the variables.
So that change that when you call on a local to global.
They are already global. So yeah, these ones are already global. So let me just show you by yeah. So my car on, right? So whenever you call my car dot on, so my car is already declared object, and on my car dot on is an attribute that's in my class, right? That's here, okay. But every time you see you're calling that outside of the class. And it used to be it used to be false, right? It used to be off, but then you start it, becomes on, and then you turn it off, it becomes off again. So indeed, that's so once you do the initialization, those variables are all global.
What about the ones that are defined later on? Like when you define start self. What about self.on equals true? That's also.
Oh, that's a function. So these are the functions that you will need to call it before.
You gotta call it.
Yeah, exactly.
Okay.
Exactly.
All right.
So yeah, these are the operations that you once you call them, then it will assign do assignment, right? But let's try this. Okay, so here I have my color on, and then I do my car dot on equals to true, and then I call it again, and what happens is yeah, I can change it also from the outside, or I can change it using the predefined methods within the function. That's within the class. Okay, so let me do the comment here so that so these are attributes, very important. Okay, attributes are now global once initialized. And then that's a calling method to change value. Okay, that's direct rewriting value. So you see, both ways can change the value of the attribute. But now, what's different here is that you should know. So you should know the object name and the feature name at the same time to be able to rewrite it. So currently we know, okay, my car.on is the attribute for whether the car is on or not. So I can rewrite it in directly. Okay. But then in all kinds of classes, right? Let's say big packages. So there are attributes you need to dig into the code to see what attributes they are using. So that's why they have this kind of like document for what kind of attributes are available for you to manipulate and what are sort of more restrictive. So that's from the programming perspective. Some things you would want to make them uh, local. So yeah, right. So very good point. So these are functions because these are defined as functions. So indeed, the operations within are in local. So once you call, you will be doing something to the data, but otherwise they will not be executed. So yeah. So indeed, there are certain things you would want to hide, but for the features, they at the moment they are just global variables.
Is there a limit on the amount of classes you can have in one code, or can you have like multiple classes and then call on different attributes from the multiple classes?
Yeah, well, you can just make sure to not have really ugly overlaps. But basically, depending on the way that we define the variables, right? So like we just mentioned, for every class, okay, for the class car, then essentially given the name of your object and the feature, you would have like filling out this variables. So if you have some overlaps, then that's really saying, okay, you are using the same object name and you're overlapping the same feature. So that will cause you some issues in the code. But then yeah, other than that, you are free to do whatever you want.
Okay,
Yeah.
so like you could make you could initialize more attributes through another class by like focusing on, in the example of the car, like the size of the motor, transmission, everything like that.
Later.
Systematic.
Later we're going to talk about what's overriding because here we have a car. Then later we're going to have a sports car that's faster. So it's going to be like a subclass of the current class. So there could be something done. But yeah, well, to avoid overlapping, I would say not to make it easy to overlap. And of course, there are things that you can do when you so there are inheritance. So that's that item that we're going to talk about in lecture 8. This here inheritance. Okay, so for a class that you already defined, if you want to specify and give some special subclass, and then there are things that you can inherit, and then there are things that you can also modify. So that's a little bit different, but yeah, these things can be done. Yeah. So that's good. So yeah, that's these are pretty much it about the beginning part of object-oriented programming. At least we know the three terms. Okay, what's an object? What are the attributes? And what are the methods? So you guys can yeah. So let's play a little bit more with the second gear. Okay, so let's change my car to second gear. By definition, our speed now is 30. Okay, so but if you think about whether the car is true is on or not, so let's change this. My car is on, so let's run this again. So this remember the car is not on. Okay, so it's false to be on. But if you look at the speed, the car is wait. Okay, let me change to second gear, and now the speed is 30. Okay, so there's something weird going on right here. So remember the way that we code it, right? The car is off, but when you but you can switch to second gear in according to your code, and then the speed shows 30. Okay, so that's something not very reasonable. So you may want to prevent it when you are doing a more realistic coding. But yeah, that's pretty much it about the section 7. So you guys can start with the live coding session to play with building your class of houses. Right. For live sessions, live coding session 7, I would say, yeah, well, why not? Let's look at question 5. Make a new class called house, and you want to, of course, firstly, put the following attributes: the address, the style, year built, number of units, number of floors, and also make the attributes and methods that you want. But of course, make sure to implement the things like doors are closed or not and windows are closed or not. Right? Yeah, and if you look at question 5, like part B, right? So you can do many kinds of options like whether there's the lights are on or off, right? Whether the heat is on or off, right? So these are things that you can play with. All right, one quick thing to mention is in here, if you look at the house class that I just established, so here these variables, they are not really critical. So you can just use A, B, C, and D associated to whatever global variables that you want to assign. The upside is it's less typing, but the downside is that when you're trying to let me just cut the function call. So let me just cut this. So let's say I want to get the hint, right? So you see, then if you're not using the predetermined variable names instead of A, B, C, and D, then you kind of lost track of what you input you want to fill in. Uh, so yeah, that's the reason why people would also just use the attribute names for the variables because it is really a freedom of choice. But make sure that the global variables, okay, is always going to be self dot. So self is reserved. Okay, self dot whatever attributes that you want. So that's basically to help you calling your variable for later use. Yeah, so before I let you guys go, one thing to quickly mention is that okay, so writing the status of whether doors are locked are open, they are not really challenging, but one thing I like to mention is that make sure to write an F string for checking windows and checking doors. So you may want to include enough information and it's readable so that let's say basically you want to answer, okay, remember whether doors are locked or not, they are true or false statement, true or false Boolean variables. So you can include that in the sentence. It's saying it's true or it's false that the windows are closed at the address, right? So you can also include a special address instead of your object name. Okay, so object name could be something really weird, like my favorite house or my last home, but the address may be more direct. Okay, so let's just calling those variables self address. Check doors, check windows. Yeah, so make sure to play with the code, and we will continue at the beginning of next class with the live coding.